Okay, this video is for the two 25-minute FRQs that were part of your FRQ 4. I have a number of these that you're going to continue to look at over the next couple of weeks. They were created by a gentleman who has long been part of the calculus community. He has read for the test, which means he's graded FRQs in the past a number of times, so he's I'd say fairly well versed in kind of College Board's strategies for FRQs. And so he created these and shared them with AP calculus teachers in case we wanted to use them in our class. So because he is respectable, I am choosing to use them for us. His best guess when he created these is that he thinks that the 25-minute FRQs will probably be out of 15 points as opposed to the typical 9. He's also guessing that the 9-point FRQ, the 15-minute one, he thinks might be worth 10 this year. Again, this is all speculation at this point. College Board still has not released that, and honestly, they might not before the AP test. They might not tell us how many points each FRQ is going to be worth. But we're going to go with what the gentleman who created these did, which is we're going to make this a 15-point FRQ. And I will show you kind of where he would break the points down based off of what he's created here. Okay? On your AP test this year, you will not have a problem that requires you to use a calculator. So that's why I put no calculator required. However, if you used a calculator, that would not be wrong. You just would need to make sure that you still showed all of your work. Right? Your calculator is there to aid. Your calculator would be there to help you double check, but you would have to show all of your work. You will not need to use it. Same, I guess, rules in terms of using notes, right? You are allowed to use notes. I know that's going to be tricky for some of us who feel like we're wrong for looking at our notes as we're taking our test, but you're allowed to use your notes. You need to make sure that you aren't expecting that you're going to do all of your review as you take the test. You will have 25 minutes to do this problem. That's it. Okay, so if you have not been doing your review beforehand, you're going to be in trouble. If you think you're going to be able to read all of your notes the entire time, well, it's going to be a little bit problematic, okay? And so we're going to be talking over the next couple of weeks about strategies for organizing our notes and organizing our thoughts so that as we head into the AP test, we've maybe tabbed our notebook and highlighted things and maybe created little summaries of our units, kind of like what we did back in Unit 3 with our graphic organizers. So you're going to want to think about organizing your thoughts, organizing your notebooks, because it's not wrong to use your notes. Right? You just still have to show all of your work and you still have to fit it in the 25 minutes that's allowed. Okay? Okay, so here we go. This 25-minute FRQ, we start with consider the differential equation dy dx equals 2xy squared, and they ask us to sketch the slope field at the 15 points indicated on the graph. Okay? And so then you would plug in each of your points to your dy dx here. So say we started at -1, 2, plugging in -1, 2, we should get -8, which is a pretty steep negative slope, right? -1, 1, plugging that in, -1, 1 gives a slope of -2, which is a little bit less steep slope than -8. Okay, -1, 0, we get a 0 slope. Okay, -1, -1, a -2 slope. And -1, -2, a -8 slope. Okay? All of the points on your y-axis give you a 0 slope. And then back here at 1, 2, we have an 8 slope. It's pretty steep. 1, 1, a 2 slope. 1, 0, a 0 slope, 1, -1, a 2 slope, and 1, -2, an 8 slope. Okay? And when he broke this one down, he decided that this would be worth 2 points. 1 point would be for the 0 slopes, So if you had your 0 slope all the way down the y-axis and these two on the x-axis, then you got 1 point, and 1 point for the other slopes, which need to account for signs. So these ones should be negative, these should be positive, and then relative steepness. 8 should definitely be steeper than 2. Right? Okay, B, we have find the second derivative in terms of x and y. Well, I've got my first derivative, so taking my second derivative, okay, this back here is product rule. I've got two things being multiplied together. So we'd have 1, 2x. d2, derivative of y squared, is 2y dy dx. Plus 2, which is my y squared, d1, which is 2. And then you would need to make sure that you did fulfill their clarification or their qualification, which is in terms of x and y. That dy dx is not in terms of x and y. Okay? And so I do need to take a moment and plug my dy dx, my 2xy squared, into that dy dx. Okay? Or you could simplify this further to, let's see, what would that be? That would be 8x squared y cubed plus 2y squared, if you wanted. Okay? This one he also made 2 points. 1 point for the product rule element with your implicit differentiation. You did need to have that dy dx there. And then the second point came from getting it to be in terms of x and y. And again, there's partial credit if you make a mistake with your derivative, but you still get it in terms of x and y, right? You get one of your 2 points, right? Again, if there's questions on partial credit, send me an email. I'm more than happy to check that for you. Okay, C, we have find the equation of the line tangent to the function y equals f of x at the point 1, 2. Okay, so let's go ahead and do that first. Equation of the line tangent is y minus y1 equals m times x minus x1. Right? In this case, my y1 and x1 are 1, 2, so we have y minus 2 equals whatever my m is, x minus 1. Okay, so then the question is, well, what is my m? Well, m is slope, and what is slope the same thing as? Slope is the same thing as derivative. That's my derivative equation. That's my slope equation. Now, we've talked about this several times, but one more time today. Okay, I cannot put that 2xy squared into my m spot down here. 2xy squared represents every possible slope. I want one very particular one, the one that exists at 1, 2. And you actually already found that, right? The slope that exists at 1, 2, you did that over here. That slope was 8, right? The derivative, let me write this down for my visual learners. The derivative at 1, 2 is 2 times my x, which is 1, times my y squared, which is 2 squared, which is 8. That's my m, right? That's what's going in there. Okay? So we found our equation of line tangent. Use that equation to approximate the value of f of 1.1. This was done also in, I think it was the FRQ3 video. Might have been FRQ2, but I think it was FRQ3. We did one of these approximation ones, which just means use your equation, plug in 1.1. So x is 1.1 here. So we have 8 times 1.1 minus 1, adding the 2 over. Okay, you got your approximation. And then I would not simplify. It's a waste of time, especially since 25 minutes is going to be new for a lot of us. You want to save time in as many places as you can for this year. If you did simplify, you'd get 2.8. Okay? And then final bit, is the approximation greater than or less than the actual value of f of 1.1? Give a reason for your answer. Honestly, I think this last part is the most challenging piece of this particular FRQ, which is figuring out if your approximation is greater than or less than. Okay, what this hinges on is what this graph looks like. If the graph of f is concave down, like that, then my tangent line approximation would be an over approximation, right? It'd be greater than, because that tangent line would be above my graph. If my graph is a concave up graph, if f is concave up, then my tangent line approximation would be less than, because it'd be below my function. Okay, so we have to figure out, okay, well, which one do I have in this particular instance? Is this concave up or is this concave down, so that I know what my approximation is? Okay, well, what does it mean to be concave up? What does it mean to be concave down? To be concave up, my second derivative has to be positive. It comes out of 3.4. To be concave down, my second derivative has to be negative. Okay, and so that becomes my question. What is my second derivative at 1, 2? Okay, well, my second derivative is up here, and this is where, again, you'd have to be careful. If you took your second derivative and got the wrong second derivative, make sure you don't double dock yourself, right? If you used your second derivative to answer this question, you might then get the quote-unquote wrong answer, but again, if you used your second derivative, you're still going to get the points. So again, if there's a question on that, snap a picture of it, send it my way. I'm more than happy to check it for you. Okay, but this second derivative, if we plugged in our 1, 2 to our second derivative here, 2 times my x, which is 1, times my 2 times my y, which is 2, times 2 times my x, which is 1, times my 2 squared. I maybe shouldn't have drawn my picture so close to my work. Sorry, get a little scrunched here. Plus my y, which is 2 squared, times my 2. Okay. I'll put the equals down here instead of off to the side because I ran into my picture. Equals, this is 2 times 2, 4, 8, 16, 64, plus 4 times 2, which is 8, which is 72. My second derivative is positive, so therefore my graph is concave up, right? Since my graph is concave up, that tells me that the approximation is less than the actual value of f of 1.1 because f of x is concave up at 1, 2, since the second derivative is, actually let's do, is greater than 0 at 1, 2. It's positive. Okay? Okay, and when he created this one, he made this one worth 4 points. Again, I think that last one's the hardest in my opinion. But again, you might differ. I think this last bit's the hardest one. This one was worth 1 point. Being able to articulate that it is less than with a reason. And you might have found a different reason. Feel free to let me know if you came up with another reason why you knew it was an under approximation. I'm more than happy to check whether or not that is correct. It's possible there's another way through the problem, but this is how I did it. So 1 point for your saying you're less than with a reason. 1 point came from solving for m, knowing that m equaled 8. 1 point came from setting up your tangent line equation. So again, obviously if you had misidentified your slope, didn't get 8, but you put your slope, whatever your wrong slope was here, you'd still get your tangent line equation. And 1 point came from your approximation, same thing. If you misidentified the slope and so had the wrong equation, You'd lose the slope point, but you get the equation point. And if you use your equation, even if your equation is wrong, if you use your equation and plug 1.1 into your equation, you still get your approximation point, right? As long as you haven't oversimplified the problem. Okay, and then last but not least, part D is kind of the one we're expecting when it comes to these slope fields differential equations, which is finding a particular solution. He did his breakdown very similarly to kind of how you've seen on your other particular solutions here, which is step 1, separating your variables. And so in this case, that would mean dividing the y squared over and multiplying the dx. Okay, step 2, integrating both sides. So this one is not the natural log of y squared. This is y to the negative 2, and so I'd have to add 1 to the exponent and divide by the new exponent. This would be negative 1 over y. For here, this is x squared plus c. I'm going to pause here a second, give you some of your initial points. This entire problem, by the way, was out of 7. 1 point came from separating your variables. And then this one step here was actually worth 3 points. 1 for this integral, 1 for that integral, and 1 for the plus c. Okay? Now, if you made a mistake here and wrote natural log of y squared instead of negative 1 over y, you did just lose that integral point. However, if you wrote x squared plus c, you did get 2 of your 3 points, right? And like we've talked about many times, at this point, if you wrote natural log of y squared, all the rest of your work is technically speaking going to be quote unquote wrong. It's going to be different than mine, different than the answer key, but you can still continue to get points because putting natural log of y squared is not oversimplifying the problem. It's making an error in your integral. Right? And so where you'll lose that point, you will continue to gain points if you use your natural log of y squared correctly. And so if you're looking at your work going, I don't know if I did, take a picture of it, send it my way. I'm more than happy to check it for you. Another quick reminder, based off of years past, again, I don't know that they will continue to do this year. They just have every year so far, which is if you have a particular solution that shows up on your test, okay, you will want to make sure of a couple of things. 1, make sure you separate the variables because in years past, they will stop grading that part of the problem if you don't. Also, you'll want to make sure you have the plus c because same thing in years past, if you forgot the plus c, they will stop grading your problem, that part of your problem. And so make sure you remember those 2 pieces when it comes to particular solutions. Again, I don't know that that will happen this year. I don't. I just know that's what's happened in the past. Okay? Okay, your next 2 points come from the same place they always have, which is you need to solve for c and you need to solve for y. Depending on what order you do that in, you will get a very different looking answer. I know working with you guys in class and kind of getting and looking at the work you've been submitting on Google Classroom, it seems like most people are going with solving for c first. So I'm going to go ahead and do that in this video. Okay, my y is 2. My x is 1. 1 squared is 1. This is subtracting that 1 over. C is negative 1.5. Or negative 3/2 if you prefer that. Okay? And then taking that c and plugging it in. Okay? We have negative 1 over y equals x squared minus 1.5. And solving for y, different ways of doing that. I'm going to go ahead and multiply the y over. And then divide that x squared minus 1.5. Okay, so you got 2 more points, 1 for solving for c and 1 for solving for y. On the answer key that I write up, I'll make sure that there are some other ways that this equation could look. So hopefully I will catch how you wrote it if you did write it differently than me. And again, if I don't, because I'm not going to be able to write them all, but if you have it written differently than me, it's not necessarily wrong. It might just be different. And if you're not comfortable assessing that, send me a picture. I can check it for you. Okay? Okay, so the last point in this one, because again, I did say he made this one out of 7, so 1, 2, 3, 4, 5, 6. His last point came from that statement, which is use that function to find f of 1.1. And so same thing, if you made a mistake and so got a wrong, quote unquote, wrong equation, but you plug 1.1 into your equation, you can still get that approximation point as long as you haven't oversimplified the problem. Again, you don't have to use a calculator. You don't have to simplify. So I wouldn't. I would leave it right there and call it good. Okay? Okay. Second one and last one for this was a tabular data one. This came from the same gentleman. All of the 25-minute ones that we're going to do here at the beginning come from this gentleman who's been a grader, like I said, been involved in the College Board community. So he's reputable, right? Again, he made it out of 15 points because that's his guess for how the 25-minute will or might be graded this year. And again, it's still a guess. One more time. We still don't know for sure. We are guessing. Okay? It says, Alice and Bob are riding the scenic skyway at Nobel's amusement park. Alice's position in relation to the entry to the ride is given by the function a of t. And so this stood out to me. I thought about changing it, but I was like, you know what? It's a good thing to leave and just to talk about it one more time. You're going to want to be careful from here on out. Okay? Alice's position is given by a of t, not her acceleration. It also means you're going to want to be very careful about using a of t to talk about acceleration. A of t is now not acceleration. A of t is Alice's position. I thought that was a little bit tricky, and again, I considered changing it because I've never seen anything quite that tricky before, but I don't know that it wouldn't happen, and so it's a good thing to talk about. Be very careful about what variables have already been used. Since a of t is already used to be Alice's position, make sure a of t is never used as acceleration. You could use like an a sub a of t for like Alice's acceleration. You could do a sub b of t for Bob's acceleration. But make sure a of t is now only used to reference Alice's position. Okay? Bob's position in relation to the entry to the ride is given by the function of b of t. So b of t is Bob's position. Okay? Alice's velocity is measured in meters per minute. So we've got some units there. And it can be modeled by this function here, that's Alice's velocity, so v sub a of t. On the time interval 0 to 8, so we do have a restricted interval here, which is the length of a ride. Bob's velocity, which is v sub b of t, also measured in meters per minute. Is modeled by the table below. At t equals 0, Bob gets on the ride. In other words, b of 0 equals 0. Which, as I've said a couple of times, always makes me think of the desired position formula. So this is Bob's position, so it would be 0, my given position, my given time of 0, desired time of t, and it would be Bob's velocity that would go inside. Okay? Okay, so here we go. A, find Alice's acceleration at t equals 3. So again, make sure you're careful to not call it a of t. What we can do is call it a sub a of t. Alice's acceleration. Okay, which is, how do we find acceleration? Well, it's the derivative of velocity. And that's Alice's velocity up here. So its derivative, the acceleration, would be negative 6t plus 24 plus 0. Okay, and then we are finding that at t equals 3. Which is negative 6 times 3 plus 24. Which again, I would highly recommend leaving it alone. You don't have to simplify. If you did simplify, this would give you 6. And then indicate units of measure. Well, this is acceleration. What are acceleration's units of measure? Okay, it's distance per time squared. My distance here is meters. My time is minutes. Okay, this is worth 3 points. 1 for finding the derivative. 1 for plugging in 3 correctly, which again, you didn't have to simplify. So if you left it here, that's fine, or you could make it 6, whichever one you prefer. And 1 for the units. Okay, B, using the data from the table, calculate the best approximation for Bob's acceleration at time t equals 3. So again, I can't call it A of t, but I can call it A sub B of t, Bob's acceleration, okay, which is the derivative of Bob's velocity. And we're finding the approximation at t equals 3. So actually, let me go ahead and write that in, at 3. And we've done several of these, starting first way back before spring break, right at the beginning of all this distance learning with the tabular data Riemann Sum video, which was the first time we reminded ourselves, well, we also did it in the particle motion unit, but first time we reminded ourselves in distance learning how to approximate a derivative using a table. Remember what a derivative is. A derivative is rate. It is slope, change in y over change in x. And in this case, I'm approximating it at t equals 3, which is right here. And so those are the points I'm going to use. Change in y, either 36 minus 46 or 46 minus 36, whichever you prefer. But whichever one you put first, make sure you put its x first as well. So since 36 is first, 2 needs to be first. If I put 46 first, then 4 would need to be first. Okay? And then you don't have to simplify. If you do, this is negative 10 over negative 2, which is 5. But again, you don't have to simplify. And then indicate units of measure. Again, we're approximating acceleration, so distance per time squared. Okay, this one was worth 2 points. 1 for the approximation, which again, you didn't have to simplify, and 1 for the units. By the way, you still get the units point on both of these. You still get the units point even if you approximated incorrectly, right? Don't double dock yourself. Be careful about that. Okay. C, using a right Riemann sum and the data from the table, approximate the total distance. So total distance, integral of velocity, absolute value of velocity, in meters that Bob traveled on the time period from t equals 0 to t equals 8. Okay, so we're approximating 0 to 8 of the absolute value of Bob's velocity using a right-hand Riemann sum. Okay? Okay, so coming up here, 0 to 8, all of these have a distance of 2 all the way across here. And we are going to be using the right-hand value of each of them. So the 36, 46, negative 34, and negative 2. The only thing you're going to want to be careful about with that negative 34 and negative 2 is that total distance is the absolute value of velocity. So the negative 34 and negative 2 will become positive. So first interval, distance of 2, right is 36. Second distance of 2, right is 46. Third distance of 2, right is going to be 34, not negative 34. Again, absolute values. And then last one, 2 and 2. Okay, which again, I'd leave it alone. No reason to simplify. But if you did, you'd have 72 plus 92, which is, let's see, 164 plus 68, which is, oh goodness, this is why I wouldn't simplify. Let's do this one, where 164 plus 4 is 168 plus 68 is 236. Let me quick double check. Yeah, 236. Whew. Yeah, definitely wouldn't do that one by by hand. And again, there's no reason to simplify. Okay. This one was worth 3 possible points. 1 came from considering that this needed to be the absolute value of velocity inside of your integral, right? So it considers the integral of the absolute value of velocity. 1 came from your right-hand sum approximation, and 1 came from your answer, which again did not have to be 236. If you left this here, you would get both of those points. Both the right-hand Riemann sum approximation and the answer would be generated just by this one step here. Don't simplify, you don't have to. Okay? Okay, D, we have when Bob gets on the ride, Alice is already on the ride. Assuming that Alice is 35 meters from the entry to the ride at time t equals 0, so A of 0 equals 35. Right? Let me go ahead and set up my desired position formula there. So given position 35, given time is 0, desired time will be t, it'll be Alice's velocity in there. Find the value of A of 2, which is Alice's position at t equals 2. Indicate units of measure. Okay? So we're using our desired position formula. Again, 35 is the given position, 0 is the given time associated with that given position. My desired time in this case is going to be 2. And then Alice's velocity is going in there, which is the negative 3t squared plus 24t plus 2. Okay? Which then would be 35 plus integral of negative 3t squared is negative t cubed. 24t is 12t squared, and 2 is 2t. Plugging in the upper then, we would have 35 plus, and this would be negative 8 plus 48 plus 4. And then it would be minus, plugging in the lower, but when I plug in 0 to each of these, they're all going to go to 0. So I'm not going to write that, but it would be there technically. And then you do not have to simplify. You can leave it there. If you wanted to, if you did simplify, this would be, let's see, 35 plus 44, which is 79. Okay? But again, you don't have to simplify. And then indicate units of measure. This is position. So position units are just distance units. Right? Again, that's on the first page of your particle motion packet, so that'd be like 79 meters. Okay? This one was worth 4 points. 1 point came from the integral. So taking the integral there, plus 1. 1 point came from using your initial position, which is this 35, adding 35 to it. 1 point came from your answer. And 1 point came from your correct units. So having meters there. And again, if you make a mistake, you can still earn partial credit. Everything we've talked about a number of times now. Okay? E, last one, we have using a trapezoidal summation and the data from the table, approximate the value of B of 6, which is Bob's position at time t equals 6, indicate units of measure. Okay? So Bob's position, desired position formula, we wrote down up here. 0 was the given position, 0 was the time corresponding to that position. Right? And then Bob's velocity is going inside, so 0 plus 0 to my desired, which is 6 of V sub B of t dt. Okay, and then we're using a trapezoidal sum to do that, to make that approximation. So I'm not going to write the 0 plus, because adding 0 isn't anything. Trapezoidal, 1/2, 0 to 6, so we're just doing these 3 subintervals here, just to 6. My change is 2 on all of them, and remember trapezoidal, we use both of the endpoints, not just the left, not just the right, but both. And so this would be 1/2, your 3 and your 36 times your 2, your 36 and your 46 times your 2, and your 46 and your negative 34 times your 2. And then make sure you stop. It's very tempting to want to use that 4th subinterval in the table as well, but that goes all the way to 8. And I'm just approximating from 0 to 6, so I would stop at 6. Okay? And then one more time, sorry, I know I'm a little bit of a broken record, but I'm trying to kind of hammer it home. You don't have to simplify, so leave it alone. That is your B of 6 there. If you did simplify, that would be, let's see, 1/2 and 2 would cancel, so 39 plus 82 plus 12, let's see, which is 39 plus 94, which is 133. Ugh. Yeah, again, don't do that. And then this one was worth 3 points. 1 point came from your trapezoidal sum. 1 point came from your answer, which again does not have to be simplified, so that trapezoidal sum is also your answer. And 1 point came from using your correct units, which would be meters. Obviously, so if you had gone all the way to 8 instead of 6, you would have gotten one of your 2 points for the trapezoidal and the answer here. You could have still gotten the units point if you went all the way to 8, and you'd get one of these 2 points. You'd get 2 out of 3 if you went all the way to 8 instead of stopping at 6. Okay? Okay, so if there are questions on either of those 25-minute ones or any of the 15-minute FRQs in the other video, let me know. I am definitely here for you guys. But that's FRQ 4.